Okay, guys, welcome to my YouTube playlist, Smarter R. So today I will show you how to do the statistical performance analysis for to assess the performance of CMIP6 data based compare with the observed data, which is a CHIRPS rainfall data. So we'll do a monthly rainfall data. We will run the statistical performance to see the performance of the GCM. We have 28 GCM that monthly rainfall data we have previously downloaded. So we want to see the performance of this GCM based on the statistical metrics. So let's dive into this one. Let me share the screen. Okay. Okay, put it like this. So the code is pretty simple. It is a validation process. We want to assess the performance of the GCM compared to the observed data. So this is a code repeat because we want to run one by one, GCM one by one. So we use a library matrix here. And then we also use that library HydroGof. Okay, if you haven't installed this package, you can install it first. And then we go to our working directory. So in our working directory, we must have our CHIRPS rainfall data. So this is my CHIRPS rainfall data in GCM PR extract here. So my rainfall data is CHIRPS rainfall for Peninsula Malaysia, which is grid with 0.25 resolution, monthly rainfall from 1981 to 2014. So when we want to compare the performance of CHIRPS rainfall and the GCM, we must have the same period of time from 1981 and 2014. For my case, I used that one, which is more than 30 years for climate assessment. So let's open this data, CHIRPS PM grid, this one. So this is my data. I have year here and monthly here from 1981 to 2014, and V1 until V178 is the grid point for Peninsula Malaysia. So if you want to see how the data is actually for Peninsula Malaysia, see all this CHIRPS rainfall for all this grid point over the Peninsula Malaysia. So I have extract the CHIRPS rainfall data. If you don't know how to extract CHIRPS rainfall data, you can watch my previous video. So for 178 grid point here, I have extract this data for monthly rainfall. Okay. Now we must run this data, CHIRPS rainfall, and under the one we must have our GCM data. And for this case, I want to compare CHIRPS data with GCM Thai ESM1. So Thai ESM1 is where is it? Yes, now PM Thai ESM1. This one from 1981 to 2014 also. So this is the GCM dataset. I have arranged it together the same thing, the same way I prepare the CHIRPS data, which is year, months, and then grid point of the GCM. Similar grid point, similar resolution, similar location. Because when we extract this GCM just now, previously we extract it at the same location with the CHIRPS rainfall. Actually, the resolution is different, but we do bilinear interpolation so that it will match with the CHIRPS rainfall data so that we can compare the performance between CHIRPS rainfall data and the GCM. Actually, we want to assess the performance of GCM to simulate the CHIRPS rainfall data. If the statistical performance is good, then the better is that GCM compared after we compare with CHIRPS rainfall data. Okay, now we run this GCM, run this file, and then we run this CHIRPS rainfall. We want to read only the rainfall data for grid 100, for the grid number 1 until grid 178 just now. For both of the GCM and CHIRPS rainfall data, we want to read the third column until column 180. So 180. So only the grid point V1 until 178. So this is for observe, and this is also the same thing for GCM. And after that, we run the function GOF to compare, to run the to get the result. statistical performance. This is the code only to compare between observation, CHIRPS, and GCM. It will compare the statistical performance of grid V1 compared with grid V1 for GCM. So after that, we run this one. Okay, we get the result already. Now we paste the result, the validation for Thai ASM2. So this is for example. So we run this one. Okay, now we get the result here. So the result is, see, we get the performance for, you see, we have like 20 statistical performance that we can use to compare the performance of GCM. So this is only for Thai ESM1. So we have ME, mean error, mean absolute error, mean square error, RMSE, NRMSE, p-bias, RSR, RSD, NSE, MNSE, RNSE. D is degree of agreement, modified degree of agreement, RDCP, persistent, R square, BR square, KGE, VE, KGE, and VE. So 20 statistical performance. So all the result is here for each grid point. The performance of the GCM we can see here. You see, mean absolute error is about 100, something like that. Yeah. So we get all we can compare the result for each grid point compared to observed data, which is CHIRPS infrared data. So this is the result that you get. Whatever you want to do with this result is up to you. Which statistical performance that you want to use for analysis is up to you. But usually I will use like MAE or NRMSE, p-bias, NSE that usually people use, MD, modified degree of agreement, CP, R square, KGE. That is the statistical metrics that people usually use. But you can up to your analysis, which statistical performance that you want to do. So you see, just only one code here, one line of code, you can do a lot of analysis by using GOF function here. So I think that's all for today. Good luck with your research. You can just watch this video and try to copy my code here. If you want to do research collaboration, you can contact me. I will share the code. Otherwise, you can just watch this video and you can try to copy the code that I write here. I think that's all for today. Thank you for watching.